Good morning students. Today we are going to see the topic breakdown mechanism. What is mean by breakdown? PN junction diode அதை reverse biasல connect பண்ணும்போது ஒரு particular voltageல deflection region full destroy ஆகும். அப்படி destroy ஆகும்போது diode large amount of current allow பண்ணும். இதைத்தான் நம்ம breakdown சொல்றோம். The reverse current or the reverse saturation current due to the minority charge carrier is small. If the reverse bias applied to a PN junction is increased beyond a point, the junction breakdown and the reverse current rises sharply. The voltage at which this happens is called the breakdown voltage, and it depends on the width of the deflection region, which in turn depends on the doping level. A normal PN junction diode gets damaged at this point. Specially designed diode like Zener diode can be operated at this region. Zener diode can be used for the purpose of voltage regulation in circuit. There are two mechanisms that are responsible for breakdown under increasing reverse voltage. One is avalanche breakdown, another one is Zener breakdown. The first one, Zener breakdown. This is a PN junction diode. Heavily doped PN junction have narrow deflection layer of the order of less than 10 to the power of minus 6 meter. Reverse voltage junction across increase பண்ணும்போது electric field 3 into 10 to the power of 7 voltmeter minus 1 narrow layer form ஆகுது. The electric field covalent band break பண்ணி electron corpus create பண்ற அளவுக்கு ஸ்ட்ராங்கா இருக்குது. This effect is called Zener Effect. Increase in reverse voltage produce a large number of charge carrier. The very low resistance in the breakdown region. Breakdown region la the junction la very low resistance இருக்கும். The process of emission of electron due to the rupture of band in the form of lattice due to the strong electric field is known as internal field emission or field ionization. The electric field required for this is the order of 10 to the power of 6 voltmeter minus 1. The second one, avalanche breakdown. Avalanche breakdown occurs in lightly doped junctions which have wide deflection layer. Electric field breakdown produce ஆகிற அளவுக்கு ஸ்ட்ராங்கா இருக்காது. Thermally generated அதாவது heat energy நம்ம generate பண்ணி minority charge carrier electric field accelerate பண்ணி sufficient kinetic energy இது கொடுக்குது. இது deflection region உள்ள போகும்போது covalent band break பண்ணி electron hole pair create பண்ணுது. The newly generated charge carrier are also accelerated by the electric field, resulting in more collision and further production of charge carrier. The cumulative process leads to an avalanche of charge carrier across the junction and consequently reduce the reverse resistance. The new charge carrier electric field கூட accelerate ஆகி collision ஆகி charge carrier produce பண்ணுது. இந்த process of charge carrier junction ல produce பண்ணி resistance reduce ஆகுது. The diode current increase sharply. The next topic, Zener diode. Zener diode is a heavily doped silicon diode used in reverse bias condition and is named after its inventor, Clarence Zener. It is specially designed to be operated in the breakdown region. The doping level of the silicon diode can be varied to have a wide range of breakdown voltage from 2 volt to over 1000 volt. Zener breakdown occurs due to the breaking of covalent bond by the strong electric field set up in the deflection region by the reverse voltage. It produces an extremely large number of electrons and holes which constitute the reverse saturation current. The current is limited by both external resistance and power dissipation of the diode. An ordinary PN junction diode except the cathode lead approximating the shape of Z letter. The arrowhead point in the direction of conventional current. Black ring indicate the cathode lead. The next one, voltage current characteristic of Zener diode. Today we study the forward and reverse characteristic of a Zener diode. The forward characteristic of a Zener diode is similar to that of an ordinary PN junction diode. It starts conducting approximately around 0.7 voltage. The reverse characteristic is highly significant in Zener diode. Reverse voltage increase பண்ணும்போது small amount of current வந்து produce ஆகும். Zener diode reverse voltage breakdown voltage க்கு equal increase பண்ணும்போது current உடைய value வந்து sharp increase ஆகும். While in Zener diode, when the reverse voltage increase to the breakdown voltage, the increase in current is very sharp. The voltage remains almost constant throughout the breakdown region. The breakdown region la voltage வந்து constant இருக்கும். IZ maximum represent the maximum reverse current. If the reverse current is increased further, the diode will be damaged. The important parameter of the reverse characteristic of VZ is the Zener breakdown voltage, IZ minimum current to sustain breakdown, IZ maximum current limited by maximum power dissipation. The next one, reverse bias. The Zener diode is operated in the reverse bias. The voltage greater than VZ, the current less than IZ. Voltage increase பண்ண current உடைய value வந்து less than ஆகுது. The reverse characteristic is not exactly vertical. It means the diode possesses small resistance called Zener dynamic impedance. Zener diode small resistance இருக்கும். Small resistance அப்படினா it is the inverse of the slope in the breakdown region. It means increase in the Zener current produce only a very small increase in the reverse voltage. So this can be neglected. In the voltage of an ideal Zener diode does not change once it goes into breakdown. It means that VZ remain almost constant, IZ is increase considerably. VZ constant இருக்கும், IZ வந்து increase ஆகும். Some application of Zener diode. The first one, voltage regulator. Second one, calibrating voltage. Voltage measure பண்றதுக்கு யூஸ் ஆகுது. Provide fixed reference voltage in a network for biasing. Fourth one, protection of any gadget against damage from accidental application of excessive voltage. திடீர்னு excess of voltage வரும்போது அந்த appliance வந்து damage ஆகாம protect பண்றதுக்கு இந்த Zener diode வந்து யூஸ் ஆகுது. The next one, Zener diode as voltage regulator. A Zener diode working in the breakdown region can serve as a voltage regulation. Breakdown region la act ஆகுற Zener diode voltage regulator work ஆகுது. Input voltage VI or load current IZ vary ஆனாலும் output voltage வந்து constant இருக்குது. In this circuit, the input voltage VI is regulated at a constant voltage VZ. Zener diode, that is Zener diode. At the output represented V0 using a Zener diode. The output voltage is maintained constant as long as the input voltage does not fall below VZ. Input voltage VZ கீழே below வர output voltage constant இருக்கும். When the potential developed across the diode is greater than VZ, in the diode move into the Zener breakdown region. It conducts large current through the series resistance RS. In the total current I passing RS equal to the sum of the diode current I2 and load current IL. Therefore, I is equal to IZ plus I of L. IZ is a diode current, IL is a load current. The total current is always less than the maximum Zener diode current. The condition V0 is equal to VZ, the output voltage is regulated.